Welcome to solverfy.
Hi everyone, so what we have is the motion of a particle and given to us in the form of a vector. This particle is moving in a spiral that has a vector position of 2 cosine of 0.1 t I hat plus 1.5 sine 0.1 t j hat plus 2 t k hat. What we're asked to solve for is the coordinate angles alpha, beta, and gamma when the time is equal to 8 seconds. So what we're going to do first is get our velocity and acceleration vectors. So our velocity will just be r dot, and this will be equal to negative 0.2 sine 0.1 t I hat plus 0.15 cosine 0.1 t j hat plus 2 k hat. Next, we're also going to get our acceleration vector, which is just going to be r double dot, so the second derivative of our position vector, and this will give us minus 0.02 cosine 0.1 t I hat minus 0.015 sine 0.1 t j hat. So when we evaluate this and our velocity vector at t equals 8 seconds, we'll see that our velocity vector at 8 seconds is going to be equal to negative 0.1435 I hat plus 0.105 j hat plus 2 k hat. And our acceleration vector at t equals 8 seconds will be equal to negative 0.0134 I hat minus 0.01076 j hat. Next, what we can do is simply take the cross product of v and a, which will give us the binormal vector, which is going to be perpendicular to the plane that contains the normal and tangential axes. So what we can do is take the cross product, and we'll see that this vector v, which will be equal to v cross a, gives us a vector that is equal to 0.0215 I hat minus 0.0279 j hat plus 0.003 k hat. Next, what we can do is solve for the magnitude of this vector. Now b, the magnitude, will just be equal to the I hat term squared plus the j hat term squared plus the k hat term squared, and taking the square root of that summation. And what that gives is the magnitude equal to 0.035338. Now what we can do is go ahead and take the unit vector of this binomial vector, and that's signified by ub, which is given as 0.609 I hat minus 0.7886 j hat plus 0.085 k hat. Now we can actually go ahead and directly solve for the alpha, beta, and gamma angles, because alpha is simply the inverse cosine of the I hat term, so 0.609, which gives us 52.5 degrees. Similarly, beta is going to be the inverse cosine of our j hat term, which is negative 0.7886, and this gives us a beta angle equal to 142 degrees. And lastly, our gamma is going to be the inverse cosine of our k term, so 0.085, which gives us a gamma angle equal to 85.1 degrees. That's it. And these right here are our final answers.